diagram and 1 and 2 go together. It's like the fourth page from the back. So, determine which forces are in the X direction, which ones are in the Y direction. How many free body diagrams should you draw for this setup? 2, 1 for each block. Once you have your free body diagram set up, do sum of forces in the Y direction for each one. That'll give you 2 equations. And you'll probably do a substitution into one of the equations with the other. This one. Minus 1. right, your free body diagram should look something like that, right? The fact that they told you it is passing over a pulley of negligible mass and friction means what? Yeah, that's basically you're living in fantasy land where this pulley doesn't matter, right? Later on, it'll matter in rotational stuff. So if it does have mass, it changes the problem. But in this case, it's just changed, all the massless pulley does is it changes the direction of the rope or string or whatever is on this one. Okay. So if I do sum of forces equals MA for this one, obviously if it's 2 mg, it's gonna go this way, right? And I'm just gonna count down as positive. So 2 mg minus t equals the mass, which is 2m times the acceleration. That's my first equation. Do the same thing over here. Now it's going this way, so tension is going to be positive, and the mg will be minus equals the mass, which is m times a. Okay. All right, now I need to decide how I'm going to solve this. So I would probably, if it were me, I would take this one and solve for t. That way I can take that and plug it in back over here. So t is equal to ma plus mg. Just add mg on each side. And then I'm going to do a substitution. I'm going to replace this t with all of that. And why did I put this in parentheses? I always have my students do that to remind myself that I need to take that negative and distribute it to both of them, otherwise my students forget. So when you plug in, I always recommend you put in parentheses to remind yourself you got to do the math correctly and distribute that negative. So that'd be 2 mg minus ma minus mg equals 2 ma. What are we solving for? Acceleration. Combine like terms, here I have 2 mg's and here I have minus mg, so that just gives you mg. And then I'm going to add ma to each side to get rid of that. So that's 3 ma's over here. And I'm solving for the acceleration, so I divide by 3m. The acceleration is m's cancel, so g over 3 or 1/3 g. Key to doing this type of problem is draw your free body diagram, then you can just see what's going in the y direction and do one for each one and then solve it as a system of equations, usually with substitution. All right, go back and do number 2 now. Let you have that. Once you have that, part 2 should be relatively easy. Remember, I've already done all this work, right? So, in all this stuff that I've done, what's the easiest place to find the tension at? sorry, it's already t equals this, right? So t is equal to m times a, which is 1/3 g plus mg, and 1/3 mg plus 1 mg is 1/3 mg. So if you have a problem like that, don't do all the work over again. In a lot of cases, you've already done the work that you need to. Just figure out where the fastest place to get your answer is. All right, let's try number 3. You'll notice that your force is at an angle, so you need to break it up into x and y components. Let me stop you for a second. If I were just to do a free body diagram on this, so this is my box here, right? How many vectors am I going to have on this box? 3, right? One will be which way? Straight down for the weight, yep, so that's the force due to gravity. And then what else? Normal force. And applied force. So that's what my free body diagram looks like. Now, this one, because it's an angle, I'm going to break it into components, right? So I'm going to break this into an x component and a y component. On the test, am I ever allowed to put these on my free body diagram, the components? No. But when I draw my own free body diagram, I definitely want to do that. So when I do sum of forces in the x direction, oh wait, you also have friction on this one too, don't you? Yeah, so I actually got another one. So friction is which way? So that's my free body diagram. But when I break this into components and I separate my equations, I can come over here and draw a free body diagram just on the x direction, which would be the green one and the friction. And then over here for y, I have the normal force coming up, the force of gravity, and I also have what else for the component? There's a component of the applied force in that direction too, right? So don't put components on a free body diagram if they ask you to draw a free body diagram, but when you're doing sum of forces in the x direction and sum of forces in the y direction, just off to the side, I would draw them like that. That way you can keep track of what's going in which direction. Okay. So now that you have those drawn, see if you can do sum of forces in the x direction, sum of forces in the y direction, and then answer the question once you have that. And if you do get done with this one, feel free to keep going. I'm not going to have time to get to all of them, so we may be skipping around. What's the acceleration in the y direction? All right, for my x direction, the black vector here is friction, right? That's the force of friction. And then minus, this is the x component of this, applied force F, so it'll be F cosine theta. And if it's moving at constant velocity, that means your acceleration is what? Constant velocity means your acceleration is? Zero. I remember calculus, right? PVA, if your velocity is constant, what's the derivative of a constant? Zero. So it follows along with that. So that tells you that the force of friction, which is also mu Fn, or mu normal, is equal to F cosine theta. This problem we're solving for the coefficient of kinetic friction, so now I need the normal force, which comes from over here. So in the y direction, I have gravity, mg, plus the component of this, which is F sine theta, minus the normal force. And what's my acceleration in the y direction? Zero, because it's not moving in the y direction. So that tells you the normal force is equal to mg plus F sine theta. So you can take that, plug it back in over here. So mu is equal to F cosine theta divided by Fn, which is all of that. That's answer choice E. So not the simplest problem, but you see if you have a visual on what's going on in the x direction and the y direction, it makes it easier to get your sum of forces. And they'll also know the constant velocity for a problem like this means your acceleration is equal to zero. All right, let's try. Have you done springs yet at all? No?
We did, no, I did it, but not in class.
Okay.
Last year we did spring constants. That's
Yeah.
about it.
That's about it.
All right, let's try number 8. Force in the spring is negative kx. So, draw your picture, make a free body diagram, do sum of forces, and then solve for what you're looking for.
Did the books all last week, or the, they did it last year. What do you spring, so we could do it again?
give you a hint, you need to find K first. It's a two-step process. Alright, there's my picture. What's my free body diagram look like? Weight or mg down, kx up. So sum of forces in the y direction equals ma. So I'm just going to call down positive, so mg minus kx equals, and what's the acceleration if it's just hanging there? 0. So mg equals kx. And then I'm solving for k, so k is mg divided by x. And they tell you the mass is initially 4. Gravity we'll just call 10. And x is the distance that it's stretched, which is 8 centimeters. Because your answers are in centimeters, you don't have to change it to meters, but you might want to change it to meters, so that's 0.08 meters. So that'll give you 40 divided by 0.08 is 500 force newtons per meter. And then that's K, and then now that says if you take the 4 kilogram mass and replace it with an 8 kilogram mass, how far will it stretch? So it's basically the same thing. Force is negative kx, so x is, or the force is mg again. So x is mg divided by k. It's the same thing as over here, so it becomes positive. I'm gonna move it over here. So the mass is 8, gravity is 10, k is 500. And 8 80 divided by 500 is 0.16 meters, because this is in meters, so that's 16 centimeters. All right, let's try 12 and 13. Let's go over 12 really quick. It says the three forces acting on an object and it's moving at constant velocity. So constant velocity means what? Acceleration is zero. If the acceleration is zero, then that means what? The sum of forces has to equal zero. So do it by components. You have to cancel this out with something that looks like this, right? And you have to cancel this out with something that looks like this, and the net result of this is something in that direction. The only thing in that direction is A. Make sense? All right, on 13, you're gonna do sum of forces equals MA, but you might have to do some kinematics too to worry about getting A. Alright, our free body diagram looks like this, right? I also know that the change in Y is 9 meters, V naught is 0, and T is 3 seconds. So why is it a good idea to write this stuff down as you read the problem? So it'll help you choose what equation that you're gonna use to find what you need, right? So I recommend you write this stuff down or annotate it right next to it, what you have. So, because they're talking about tension, it's the sum of forces problem, so. So T minus 20 equals MA. This time I do have an acceleration. Do notice that this is already in newtons, so you don't have to multiply it by gravity. So to solve for T, I need M and I need A, right? So M is just 20 divided by gravity, or we'll just call it 10, so 2 kilograms. And then the acceleration is going to come from kinematics. So if I have these three things, which kinematic equation can I use to find the acceleration? It's delta y equals v naught t plus 1/2 at squared. And this is 0. So 9 equals 1/2 a times the time, 3 squared. So that's 9, divided by 9 is 1, multiplied by 2, so the acceleration is 2 meters per second squared. And then I can plug that back in there. And that's 4 plus 20, be a force of 24 newtons, or tension of 24 newtons. All right, turn the page and do 14 and 15. All right, for 14, which the following graph shows an object where the net force is 0. If the net force is 0, what's that mean? As well, that the acceleration is 0, and velocity is constant. So number 1 shows an object that is not moving, right? So that would have an acceleration of 0. Number 2 shows constant velocity. So that one is equal to 0. And number 3 is a velocity time diagraph, so the derivative is the slope of the line, which is negative acceleration, so 1 and 2 only. And then for projectile motion, once it's been shot out and there's no friction or drag, what's the only force acting on it? Gravity, so the acceleration is the same at all points. Got about 2 minutes, so let's try number 7. right, for this one, a coin of mass M is placed on a vinyl stereo record of radius big R and moves at a constant tangential speed. So if it's a constant tangential speed, what's the tangential acceleration? 0. But what kind of acceleration does this have since it's rotation? Centripetal, right? So I'm going to replace the acceleration with what? V squared over R. And then the only force acting on this one is due to friction, so mu n, which is mu mg, equals mv squared over r. And I want you to solve for mu. So m's cancel, just divide by g. So mu is equal to v squared over gr. All right, 5-minute break.
All right, this time we'll go ahead and announce our guests. Alan McCall, Emily Spiegel, Brittany Babb, Jonah Thompson, Isaiah Walker, Chad Clement, Emily Rader, Jacob Sanders, Kayla Dearman, Natalie Dante, Ashley Smith, Samantha Bishop, Hannah Ward, Sage Anderson, and Kaylee Davies. Also, if anyone is looking for water, there in the